Hello and welcome to the capstone project for John Deere in spring 2020. Our project is called Standardized Metrics Reporting and Storage. My name is Jordan Meitinger. For UI design, we have Anna Carlson, Jaden Rosna for backend, and Wiley Andrews for tables and graphs. John Deere was founded in 1837 and not only does ag, but other markets such as marine engines, construction, forestry, and lawn equipment. Today, the branch of John Deere that we're working with is Electronic Solutions, which is located here on the north side of campus in Fargo, North Dakota. What John Deere wants is to fix a problem with department performance. They have a couple ways of doing it, but they want it all in one central location due to the fact that most of their development teams are on different programs such as GitHub, Collaborator, and different progress tracking development softwares. They need to check the overall processes such as project reviews, project defects, and team members. They want at a central location. They want all the information uniform and formatted so that they can just use one solution for all of these different items. And they also want it Python based that was be able to add on later on due to its versatility.
Hello, my name is Jaden Rosna, and I will be talking about the back end of our project. For this project, we use Django, Python, and Django REST API framework. Django allows us to create a database and then create models with certain attributes we want our data to have. For example, John Deere project information, we want a project name, product owner, team ID, and project number. Our database consists of phase type, which is the area of where the error in the code occurred, such as requirements, design, code, integration, function testing, system integration, system evaluation, and post-release. We also have projects, defects, reviews, and products. These four act in a way as products contain information for what projects are in work for this certain product, and defects and reviews are then connected to each project. After filling in what needs to be in our database, we then use Django framework to create the serializers for each models. Serializers create the native Python data types, which then can be rendered into JSON or XML, and restricts what outputs or responses in the REST API give out. From what the serializers create, we are then allowed to make the views, which takes our request and returns the correct response we want to send to the web application. When the database and REST API was all set up, we then set up the apps, dashboard, and account, each with its own models and views. For account, we made models that allowed the admin to create more users and staff users, or team leaders in John Deere's term, and super users, other admins. Account creates all information for every user and the authentication token needed to view projects, defects, and reviews. It allows the creation of what logged-in users can see and what non-logged-in users can see. Our API consists of the ability to post, delete, and get requests to attain data from team projects, review, defects, product, phase type, and account list.
My name is Anna Carlson, and I covered the front end for this project. This included making the initial mockups for the user interface, coding in the CSS, and adding light and dark modes. John Deere also specifically asked for Plotly to be used to display graphs, and while I will touch on that a little bit here, that section had its own challenges, and my teammate Wiley, who headed that part of the project, will explain in more detail once this section is complete. John Deere requested a dashboard view, so I set up a main page using Flexbox format. Each overview graph that Wiley set up has its own section here, and the user can scroll down the page to see each of them. This was initially set up to grow and shrink horizontally based on the width of the window, but at John Deere's request, we changed it to one item per line. While the current plan is to keep this in a desktop, this would allow for an easier shift to a smartphone if that route is decided in the future. Next, there's a section for information on individual projects. If the user is logged in, the projects will automatically be pulled from his or her team. However, if the user is not logged in, he or she can use the filter drop-down at the top of the list to search for the desired item. When the project is open, the user can further see more information on reviews and defects. On this page, the user is presented with some graphs for this particular item, number of defects per release, and post-release containment. If the user further clicks on a review or defect, he or she is taken to a page where he or she can view and update the individual item's information. Once logged in, the user can click on the user section. Here, he or she can change his or her display name, team, or change the theme. There are options for light and dark mode so that the user may switch between a clean, professional look in white and an easy on the eye dark mode for those who stare at their screens longer. Also, while logged in, the user can click on the Team tab. This will display other members of the team as well as the current projects. Clicking on one of these will send the user to that project's information.
My name is Wiley Andrews, and for this project, I worked on getting graphs shown onto the web page using Plotly. John Deere asked us to recreate a few graphs for them that will be displayed onto the dashboard and the project's detail pages that will represent the progress that each project is making, and the company as a whole. These graphs include a line graph displaying reviews over time, a pie chart showing the percentage of defects that make it to post-release and beyond, and bar graphs representing both defects per project phase and post-release defects by year. I also worked on displaying tables of open defects and reviews. I originally created these tables in Plotly, but due to the limitations of Plotly, I moved over to using a library called Django Tables 2. This transition made it much easier to display query sets of information to the user, without having to manually adjust column sizes, URL links, or data that overflow the cells that they are in. The graphs and tables pull information from the REST API by grabbing a query set from the model. This query set is then filtered. The filters applied include a filter based on inputted date range, 3 years by default, filtered based on project, and filtered based on whether the information is still open or not. The graphs and tables are sent from the Python code to the HTML through the use of Django's views. The HTML objects are first generated through the Plotly or Django Tables 2 libraries. Then, these objects get passed through context variables to be displayed in the HTML. We have HTML templates set up that will take these context variables and place them on the web page accordingly. The project now has 4 graphs and 2 tables that have gone through many changes over the course of the project. As I better understand the tools that Plotly provides, I can present more clean and understandable data to the user. The Plotly graphs I've implemented has improved the user experience by providing the user the information he or she is looking for.
Hello, and welcome to the demo. On the demo, we are on the home page. As you can see, there's a filter on here through the 2017 to 2020. It's a 3-year span. It changes through every day. You can change that for a different start date or a different end date. So the review tracking is for every project through this date. So currently we just have some dummy data in here showing that the graphs work and have a good representation of what it would look like in the future. Next, we have number of defects per release. So each release is requirements, design, code, integration, function testing, system integration, system evaluation, and post-release. And the number of defects can be added or changed through year by simply just clicking on the numbers on the side. It's a great feature done by Plotly. In the post-release, we have the same phases from up here, but after the function testing. So system integration, value, and post-release, that is the post-release effects. And you can also see that by the years, which is filtered at the top. Below, we have open defects. We don't have a lot of open defects. We just have a small little bit. We just only have one. You can go to the URL from here and you can see the description. There is no current description for this one, but we'll show you some other descriptions later. We have the review table, where also we don't have any open reviews because usually reviews are closed right away. And lastly, again, another representation of the post-release containment. John Deere really wanted to make sure that they were getting all their defects handled before the post-release. Scrolling back up to the top, we will go on to the next page. This is obviously the dash page, but the next page is projects. This is all done not logged in, so the users do not have to log in to view this information. On this page, we just have a simple all the projects. We can search through the project's names, through the team name, the project owner, and the primary key. The names do have to be exact when typing in the name. For the search, you just hit the nice little filter and it'll filter for you. You can click on all the projects, the project name, and it'll take you to the project detail page. Project name is right here, but the dummy data is just put there just so it's easier to see all the data and graphs and stuff like that. Like I said before, here's a description that's after the tags of the defects. We also have the project reviews on this page. And of course, this is information just for this project. So we have number of defects per release. Pretty bad that we have all these defects over here, but again, it's just dummy data. Down here, we also have the 50/50 post-release containment for this page. Going back, little tidbit right here, we have the next and a previous or first for this page, just a little feature that we added for the users. We'll quickly go to a defect real quick, just to show that the users that are not logged in can also see these defects, but they cannot change the defect or review due to the fact that they're not logged in and they're not admin or the product owner. Going back to the projects page, again, this is the projects plan, all the users can use it. The About page, this is just a little description of what this project is about and who made it. You can find the GitHub right here at the bottom, just clicking on that. Since we have gone through all of that, we can go to the login page, where I will log in quickly. Again, same page is shown, but now we have two more tabs. We have the team page, actually three more tabs. We have the team tab, the user tab, and the REST API. The team tab is where you are put on a team. Each user has a team. And when you are put on the team, it shows each team member, and also it shows all the projects. So you can have those specific projects for the team. You can also click on the thing and it'll take you to the same page that we saw before. It shows the defects and the reviews, and also you can filter through open defects only, so you can filter. We only have one open defect. Going back to the team page, you can also put in a JSON input for different tables for the team. So each team might have a different table that they want to put in there, such as like CPU times for a certain project or product. Going to the projects page, this page is similar to the other page, but this one allows you to add favorites. So you can add favorites and remove favorites. You can also click all projects, and it also has this favorite button. So let's say you're on a different team, but you were assigned to help with this project. You can add this team to your project and save that for your team. Lastly, we have the user tab. You have your email, your employee number, your name. You can change your team. Let's say you get assigned to a different team. You can change your team. You can change your color scheme. So like every other company, we have dark and light mode just in case the user doesn't have the constraints for their eyes to look at light mode all the time. All the pages are pretty compatible with it.
This is the Django REST Framework API. This allows the admin to have many options, such as to view team, project, review, defects, products, phase type, and users. When clicking on one, such as team, it shows ID and name. When scrolling to the bottom, this is how you add a new entry from the actual framework. And as you see, it has added the ID 17 with the name test. When clicking on a team instance, you can view the name. And from here, you can change from either HTML form or raw data form. When clicking on this, you can change the information through the put and patch button. The last thing you can do is also delete by clicking the delete button. This is the Django Administration page. You can see it by the URL admin and also the Django Administration header. On this page, you can view the different modules, such as account, auth-token, authentication and authorization, and REST API. When looking at an account, you can see the user's email address, date joined, last login, and is admin. You can also search and delete with the action bar. When clicking on a user, you can see their email address, password, personal info, refact, their team ID, their dark color scheme, their permissions, is active, is staff, is super user, and important dates. You can also see add account. From here, you add the email address, the name, and all other information needed. When heading to teams, you can see all teams in the server. The action bar also has all the same functionality delete, and post and patch. When clicking on a name, you can also see the team name and the JSON file associated with it. You can also delete an entry, save an entry, and add another entry. Auth token is the page that shows all authentication tokens created for each user.
Hello, my name is Wiley Andrews, and I will be showing you the Plotly graphs and Django tables used in this SMRS project. As you can see on the dashboard, we have a few graphs and tables presented, including one line graph, two bar graphs, two tables, and a pie chart. We also have project relevant graphs available that show project specific information. Going back to the dashboard, we have at the very top here an area for you to select a date range that will be viewable. By default, the date range shows the past 3 years of information, but more current start date and end dates can be selected. As you can see here, we have selected all information from January 1st, 2018 to December 1st, 2020. Here we have the information provided. I wanted to change the filter back to the past 3 years. There we go. Alright, so here's the first graph that we have here. It is the review tracking per month graph. This graph will show us how many reviews appear in a fiscal year and will increment per month. It starts out in November, and as reviews have been created, the line graph will increment. So in 2020, only one review has been created, and that is in January. However, in the year 2019, there have been 5 reviews. 1 in December, 1 in June, 1 in July, and 2 in September. The number of defects per release number of defects per release graph shows how many defects appear in each phase of development for a year. As you can see, in the requirements phase, we have 1 requirement defect in 2018, 2 requirements defect in 2019, and 1 requirement defect in 2020. The bar for 2017 does not display when there are no defects for that year. As you can see, it shows up in the design phase. The next table, the post-release defects table, keeps a percentage counter of how many defects make it to post-release, which is to say, defects that make it to system integration, system evaluation, or post-release. There are 2 tables displayed, and these tables show open defects or open reviews. These open defects or open reviews will display data and their ID, the date they were open, the project name, where found, as in which phase of development, the defect or review tag, the severity of the defect or review, and the URL is connecting to the defect or the review. Open defects will also have a description that the developer can write when they create the defect in the REST API. Note that if a developer creates a very, very long description here, the description will be shortened down to be included within the table. Also, this says description not found, but that is simply the description that the developer has put into the REST API for this defect in particular. The last thing we had to display is a post-release containment pie chart. And this shows the percentage of defects that have been captured before the defects have reached the last 3 phases, which is system integration, system evaluation, and post-release. As you can see here, 61.5% of defects have been captured before these 3 phases, and that is 8 of them, while 5 of them have gone to the post-release phases. As you can see,
there is no reviews here, and that just simply means that there are no current open reviews. The date close value, which is typically saved in REST API, is not shown because if they are here, that means that they are open, which means that there is currently no date close value. And as you can see, if we go to a certain project, we have the number of defects per release table shown here, but also the post-release containment, which shows information specific to this project in particular. Note that the other graphs did not appear here because there is already information for project effects and project reviews, and all the other tables show information based on a yearly basis, which is not relevant for each project. That concludes all the information for Plotly and Django tables. Django tables are used for these two in particular, and they automatically do a lot of information handling as far as figuring out the name of the design, the name of the phase type instead of just putting an ID in, and the same for the project. It doesn't put just the ID, it puts the name of it if possible. And Plotly also does a lot of other handy tricks, such as being able to zoom in on certain parts of the graph for more particular data. And you're allowed to zoom out, zoom in, and reset the axes back to normal.
In our first sprint, we finished the REST API for this project. This actually took our sponsors somewhat off guard since they had planned that alone would take the entire semester. Jordan and Jaden had found a framework specifically for handling REST APIs in Python, so there was no need to homebrew a new system. In our second sprint, we chose to work on the UI interface stretch goals that we had been given while our sponsors considered what else they wanted us to do. We began developing a user interface with graphs, a login system, and CSS formatted pages. Here Wiley also developed a JSON to object method to allow easier input for John Deere into the application from their pre-existing JSON files. For Sprint 3, we were showing our progress to the sponsors on a weekly basis, and we adjusted or added according to their needs. One item the sponsors were keen to have us add was the Plotly graph framework. We also added a README and more documentation. I added additional CSS for light and dark modes. I had tried to stick to a green and yellow theme to represent both John Deere colors and NDSU colors, but the sponsors requested some options that were a little easier on the eyes. Sprint 3 also included some database adjustments. For our final sprint, Sprint 4, we focused on tidying up some loose ends before the end of the project. We made UI adjustments and redid how some of the graph information was being presented. We reworked the database a little bit more so that the projects could be connected with product numbers, which in turn meant projects can be tracked accordingly. Next, we have our risks and issues section. We occasionally had some trouble having two sponsors to report to, but they communicated well with each other and it was generally not a problem. The only time this was an issue was when one of them was on vacation when we finished the REST API, and when he came back was a little confused on why we were discussing UI elements. This was sorted out by the end of the meeting, however, and didn't result in any long-term problems. One of our biggest challenges was due to COVID-19. Quarantining in response to it had made all interactions between team members, sponsors, and course instructors more difficult, as all meetings and communication had to be done online. There was some confusion with meeting scheduling with our sponsor due to this, but that was sorted out and the meeting day and time was changed. The development team and sponsors had discussed implementing password changes and resets for user accounts, but due to not having access to a John Deere emailing system and other technical problems, the idea was scrapped. It had been a backburner task for a bit, and while dropping it ultimately didn't affect the problem too much, there were man-hours spent on it.
Coming into post-mortem summary, there was a total of 160 hours as a group. 15% was getting up to speed, setup, 30% was REST API and auth tokens, 15% was functionality, such as making sure they had the basic functions of a website, 15% was graphs and tables, 10% was special features, such as like dark mode and the search features that we added, 15% was documentation, there was 92 total commits and 1.5 million additions. Lastly, the next steps for John Deere is to wipe the current data as its mock data. Next, they need to decide how the users should be added, which they can see in the README on GitHub. Next, they need to create a Python script for the request to the server for GitHub and DevTrack and all their other development softwares. Next, they need to put that script on a Linux server so that the server can run that weekly, monthly, or daily. And lastly, they need to add all other functionalities to the website. Thank you for listening to our presentation, and I hope you have a good day.